Today, the first part of our series on neural machine translation. All you wanted to know about it, but were afraid to ask.
Welcome to Globally Speaking, your program that explores everything and anything to do with language localization. Are you ready to dive into the most critical issues impacting global brands today? Globally Speaking is designed to educate, inform, and challenge everyone who's engaged in global communications. Your hosts for Globally Speaking are Renato Beninatto and Michael Stevens. Learn more by visiting our website at www.globallyspeakingradio.com. And now, here are Renato and Michael.
I am Renato Beninatto.
And I'm Michael Stevens. The New York Times, The Economist, two of the most prestigious publications in the world, have recently published extensive articles, not just short articles, but extensive ones about artificial intelligence, or AI for short, and neural machine translation. Renato, why is this important?
Oh, Mike, I frequently share content in social media with this hashtag, translation is only news when it's bad, because that's what really happens. You only hear about translation when something goes wrong. But this seems to be an exception. For the first time in a long time, I see the press talking about progress made in the language services space.
Yeah. So for this podcast, we've talked to several people who are directly involved with the neural machine translation around the world. We're going to hear from their voices, their opinions, and help us understand what Neural MT is doing, how it's affecting the business of translation.
Or not.
Yeah, right. It's said that translation is the most difficult and complicated area for artificial intelligence. It's no surprise that Microsoft, Google, Baidu, IBM, Amazon, and even Facebook use MT to brag about how technically skilled they are.
Well, that's the whole thing. I mean, it's so difficult that if they can solve the language problem, they prove their skills. But perhaps we should start by talking about Google Translate, which it was launched in 2006, and since then it has become one of Google's most popular products.
It's a regular use of just about everyone I know on a daily basis.
Absolutely. Yeah. So the data for January 2017, according to the data, Google Translate is available in 103 languages. It serves more than 500 million users on a monthly basis. And these people translate 140 billion words per day. That's 140 billion with a B, Michael.
Okay. So doing a little math there, this means Google alone translates more words in a day than all the translators in the world translate in a year.
That's a very good way to put it. But the reason for starting with Google is that they have this new strategy in the company that they call AI first. So it's a company-wide initiative. And because of that initiative, they started converting Google Translate from statistical MT to neural MT. And it hit the news that their new machine translation was indistinguishable from humans.
The news hit that it was indistinguishable from humans, but really it wasn't. Google clarified the real message. It's actually much better than it was before, but not as good as humans. Google went further to say that their efforts weren't about replacing people, but to help people.
Yeah, and we have a lot of fear in our space, and the word was out. So naturally, professional translators and the bloggers, the pundits, the media, and it became a hot topic for the language services industry as a whole.
Yeah, it's trending. It's trending, as they say.
Yeah, exactly. It's trending. So we actually, in our podcast about the predictions for 2017, we said that it was going to be a hot topic. I didn't expect it to be so hot so early.
So hot so early. But Renato, Neural MT is the latest iteration of a technology that's been around since 1950. So how do we get here?
Well, before Neural MT, there was rules-based machine translation, Systrand being the most famous, which was followed by statistical phrase-based machine translation. And this is a good time to introduce our first guest.
I'm Mike Dillinger. I've been working in machine translation for 20 years. I'm former president of the Association for Machine Translation in the Americas. and I'm currently managing machine translation at LinkedIn. My key area of interest is how to get machines and humans to work together most effectively so that we can produce systems that I like to call hybrid intelligence systems.
If you had to explain to an 8th grader rules-based machine translation and statistical, could you give us a definition for each?
A definition, maybe an explanation.
Explanation.
Okay. Actually, I think the statistical MT is easier to explain. A statistical MT system takes a lot of examples of sentences that humans have translated and actually counts up for each pair of words and each triple of words the different ways that it got translated in those example sentences. And when a new sentence comes in, it goes through each of the words and pairs of words and triples of words and says, all right, let me see what was the most common way that this word or pair or triple of words showed up in the other language. And it pieces together its translations that way, based on a big list of counts. This word got translated as that word this many times in my examples. I think that's the easiest way to explain statistical MT. There's a whole bunch of other mathematical magic that goes on to make that work better. And rule-based MT is an effort to actually capture the knowledge from a human and put it in the machine. So if the human says, aha, these words in this kind of sentence mean this, that's a rule. Mean this, show up as this in the other language. And these same words but in this other sentence actually mean this other thing in the other sentence. And rule-based systems literally take rules like that and put thousands of them into a computer so that when a new sentence comes in, you see which rules will match, and then those rules will tell us what the translation looks like. So instead of counting, it's rules.
We wanted to understand what neural machine translation was compared to the other two systems. So we went to the mastermind behind MateCat.
Marco Trombetti, tech entrepreneurs in the language industry for the last 15 years.
And where are you based?
Rome, Italy.
Okay.
Not everyone can live in paradise.
So if you were to formally define neural machine translation, how would you define that concisely for a layman, for your mother?
Yeah. So let's say what statistical was before. So we're taking a lot of examples, giving these examples to a machine, and that machine is learning which word is the translation of which word, and then learning which sequences are the translation of which sequences through an algorithm that we designed. Neural is just another approach where you first, the way data is structured is different because it tries to simulate the human brain in terms of structure of the data, structure of the learning, but also what to learn is something that the machine learns automatically. So you don't have to teach exactly what word alignment is, how to look for words, an example. It's trying to look at all the correlation there is in data. And so you don't have to teach what to look. It's basically looking at if there is any correlation within the data, it will learn it. So it's much broader approach, and obviously it's much more complex. It takes 100 times, if you want, 100 times the cost of the previous one. But at one point, it will become sustainable.
Okay, so the idea, and this is where all these terms get mixed, and you told me that they're essentially the same thing. Machine learning, neural machine translation, deep learning, these are all very similar concepts.
Yeah, machine learning is also statistical. Machine learning is a concept of being able to teach a machine how to do something that the humans does. So that was an approach. Now deep learning is a much more generalized approach to that. It's not even, also this is limited in some way, and this will be evolved, the algorithms will evolve a lot, and we'll learn from other things. But it's more generalized. But also what is incredibly interesting, and I think that's why everybody is using it, is because we human, we move forward because we're lazy. So what happens with neural is that the 1 million line of code that was statistical now are only 280 lines of code in neural. So from a developer perspective, this is extremely much easier to implement. You will have the hardware, the machine to work for you a lot and will cost a fortune, but your work as a developer is much simplified. because they delegate everything to the calculation. It will work at night to try to find something that you didn't find.
Okay, so I may be trying to oversimplify it, but in statistical, we were the ones creating the algorithm, people, and then trying to get better results.
Yeah.
With deep learning and neural networks, the machine is actually creating the algorithm. Is it accurate?
Is it correct? And in fact, if you see the evolution in rule-based, we were teaching all the rules and now to transform every single word in the position. Statistically, it's a little bit better. It's doing some work for you, but still you're teaching what to look. In deep learning, you don't even teach where to look.
And so I think also there may be, go back to rules, the rules-based, talk about a language rule. What were we in charge of then that we've given up now?
So before you were telling the rule-based system, okay, when there is an adjective, put it before the noun in English and revert it. And that's in statistical, you don't do it anymore because you will learn by looking at the word position. In neural is looking at every single other relationship that there is within those words in the sentence. So including now words that appears in the sentence that are far from them, but they're still related. And if these you can learn that those two words are related, at one point the machine will learn it.
Michael, the simplest description of a neural network is that it's a machine that makes classifications or predictions based on its ability to discover patterns in data. So with one layer, you could find only simple patterns. With more than one, you could look for patterns of patterns. And this is how neural networks learned how to identify images, one little feature at a time. This is how they are addressing the language problem also.
So we went to John Tinsley. He's the CEO of Iconic Translation Machines, a company based in Dublin, Ireland, and they help build custom MT solutions, to ask him about other applications of neural networks.
The reason people were getting excited about it for translation is because it did orders of magnitude levels of improvement in other areas, like image recognition. So people kind of take it for granted now, but the fact that you can go onto Google and you can search for blue sky landscape and go to images and it'll give you thousands and thousands of pictures of blue sky landscapes. That was all done with kind of neural image processing. And you've got a lot of cool companies, for example, like the likes of Shutterstock, who are doing things with that. Just being able to put better tags on images, people being able to find images and things like that. So there was this excitement that, this has worked. Because neural networks aren't new. They've been around for ages. And they've been having success in these application areas. And I guess Moore's Law has caught up to a point where we can say, oh, okay, we have these computers now. We have these GPUs. Let's try and see if neural MT works for language. But language is a lot more complex.
Yeah.
So it's not having the same breakthrough as it did in other areas. But yeah.
So you mentioned imaging, a couple of others that you can come to mind?
Speech, probably speech recognition, speech synthesis, because that's where statistical MT came from, was all the research that was going on for speech processing, the kind of statistical models that they had. So, and any language application, natural language understanding, parsing, part of speech tagging, sentiment analysis, all that sort of stuff, it can all be done. This is another way to do it. They can all be done with rules. They can all be done with statistics. They can all be done with neural networks.
After Google Translate, the most popular MT in the Western world is Microsoft Translator. So a cloud service that translates between more than 45 languages. It powers translations in Microsoft products such as Microsoft Office, Skype, Translator, Bing, and many others. Microsoft Translator uses an automatic translation engine that employs machine learning to generate statistical translation models, and has recently launched a tool to compare statistical MT with neural MT in 8 language pairs. You can check it out at translator.microsoft.com/neural.
My name is Chris, and I'm the Group Program Manager for Machine Translation at Microsoft.
I tested the comparison tool with my native Portuguese and French.
Yes, so English, Portuguese, English, French, the quality delta between statistical and neural is actually not that big. Mm-hmm. It is big on languages that have a stronger differing structure. than English when you translate from into English. Try Chinese or try Arabic. Actually, it's good if you don't speak Chinese or Arabic, and you see if you actually get.
I can understand what it's talking about. That's a very good point.
So the chance that you understand what this is about is much higher.
Oh, okay. Chinese and Arabic. I'll try that just for fun and see how that goes.
And I want you to look at one aspect again, as in what actually made you choose the one that you chose as better. Was it that it is more fluent and more understandable, or was it that it was more correct to the source, more faithful to the source?
I'm trying to remember. I just did a pair right now with some news from a Brazilian newspaper. So this is, and I chose the news because it had two names of financial institutions that by themselves are words with other meanings, right? So Banco do Brasil. Banco can also mean a stool.
Right.
And the other one was Caixa, which also means box. So the funny thing is that the statistical translated it as box, and the neural one translated it as Caixa, but in the middle of the sentence, further down, it translated it as box also. So it couldn't disambiguate. But overall, I felt that the tone sounded more natural. The sentences sounded more natural than... I didn't really look for accuracy. There were sections where the language was confusing, and then when I went to check in the original, it was a formatting issue. It had included captions in the middle of the text when I copied and pasted it. So they had captions for pictures and so on. So both of them were pretty good, but the statistical in this case, it was from Portuguese into English, did a better job with the names, with handling the names.
Yeah. I figured that would be the case. That statistical would win on accuracy and neural wins on fluency. Statistical, our and some of our competitors' statistical systems are in that sense more mature, as in they have gone through more scrutiny or longer scrutiny. I mean, over the life of during the last 5, 6, 7, 8 years, which has really addressed many of these shortcomings. But we see that the statistical systems, they are kind of flattening out. Adding more data doesn't help anymore, right? Tuning it here and there doesn't really make too much of a difference anyway. A year ago, if you went to the research conferences, right, there were papers on getting a quarter blue point improvement by this or that technique. In neural, you add a new layer to the network. You add something like the attention model. You have like huge improvements. So the rate of improvement on the neural systems due to, actual algorithmic improvements is much, much faster. Right?
So what you're saying is that we have pretty much plateaued in the statistical and we have a new runway with neural.
Exactly. Yes.
Okay, so we have room for improvement. Neural is getting close to statistical, and then it's going to go further.
Yes.
So if we go into the concepts of singularity, have we expedited singularity for translation, or is that was just one of new step in the path to that image of singularity? You know that Kurzweil says that we would achieve singularity in machine translation by 2019. So we're 3 years away.
I usually don't answer that singularity question. I say the machines already translate 300 times more words per day than humans do. Mm-hmm. So does that mean that machines have replaced humans like 300 to 1? Well, yes.
In the next episode of Globally Speaking, we'll look at other aspects related to machine translation in general and neural machine translation in particular.
Topics like the relationship between human translators and the machine, confidentiality, and the outlook for neural MT in the localization industry.
We welcome comments, questions, suggestions for podcasts, and on some level, constructive criticism.
Yeah, I mean, you can say that we're ugly too.
This podcast was produced by Burns360. You can subscribe to Globally Speaking on iTunes or wherever you get your podcasts. See you next time.
Thank you for listening to Globally Speaking, brought to you by Moravia. We'd like to hear your comments, suggestions, and feedback. So until next time, please visit online at www.globallyspeakingradio.com.